Well, this is going to be way better than simplifying those complex rational expressions. Solving rational equations, much straightforward, and kind of it has an answer that's a little bit more satisfying. Like, hey, x equals 4 makes this true, or x equals -1 makes this true. So it is a little bit more satisfying. So we'll start off with a super common question to ask. And I really actually like the way that they ask this. They say the algebraic solutions to this equation. So if you were to go through and solve it following all the correct steps, the algebraic solutions are 4 and -1. And I want to show you that. And then it says, why is x equals 4 an extraneous solution? So my hope is that it should be obvious to, wait, if I were to plug in 4 for x here, it makes the bottom 0, makes this fraction undefined. How could, oh, sure, undefined equals undefined. So yeah, you're not allowed to allow the denominator to become 0. So for that reason, in the very beginning, we should have said, I'm not going to allow x to equal 4. I'm not going to allow x to equal 2. If either of those comes up as a solution, I have to throw them out of the solution set. The way that they solved this, by the way, it's pretty straightforward. It's convenient, and often happens that this more complex, in this case quadratic, but it could be a polynomial, that it is made up of these other denominators as its factors. And that's the case here. This is two numbers that multiply together to give me +8 and combine to give me -6. That is x. That's a -4 and a -2. So it's x minus 4 and x minus 2. Nice. Okay, so this is 2 over that. Okay, so we have 1 over x minus 4 plus x over x minus 2 equals 2 over x minus 4, x minus 2. Multiply together. Minus 4, x minus 2. Okay, so I'm going to need to combine these together. So this needs an x minus 2 on top and bottom. So x minus 2, x minus 2. And this needs an x minus 4. So x minus 4, x minus 4. I never multiply out the bottoms because you're going to get that. It's way easier when everything is in factored form. So this is just x minus 2 is what this numerator is. And then this is x squared minus 4x. So then now I'll combine all those together and I get x minus 2 plus x squared minus 4x over this stuff equals 2 over this stuff. And I can combine, let's see, positive x and -4x. This is -3x. So minus 3x. I combine those. Let me rearrange this. So it's in the standard quadratic form. So we have x squared minus 3x minus 2, x squared minus 3x minus 2 equals 2. Well, if this is over the same denominator, the only way that these two fractions could be equal is if they're numerators, if this numerator equals this numerator. Okay, so let's set them equal to each other. So we're going to get x squared minus 3x minus 2 equals 2. It's a quadratic equation. How do we solve them? Set them equal to 0. So I'm going to subtract 2 from both sides. So let me change this to -4 and 0. -4, 0. Two numbers that multiply together to give me -4, combined to give me -3. That's a -4 and a +1. So this is going to be x plus 1, x minus 4 equals 0. So the two values of x that work are -1 and 4. Well, that's actually, so they saved you from doing all that work. So they said, we know when we solve it algebraically that 4 and -1 turn out to be the solutions. Why is 4 a problem? There. So we actually answered this quite a ways ago, but it does allow us to kind of talk about how do we solve an equation like this. This one here is actually simpler. First off, What are values of h that should be excluded from the domain? H is not allowed to equal 0. And let's see, what value of h would make this 0? It looks like -4. So h is not allowed to equal -4. I've made that promise. Now let's go ahead and multiply both sides by h, multiply both sides by x plus 4. Or you could do the butterfly thing. You could multiply this times this, and this times this. It has the same effect. Plus it looks cool. So we get 8h equals 6 times h plus 4, which is 6h plus 24 equals 8h. So I'm going to get so I'll get my h's together, minus 6h minus 6h. So I get 2 h's equals 24. H has to equal 12. Woohoo! Is 12 in my list of exclusions? No. Then I'm pretty confident that that is my solution there. Okay. How is this next one a little bit different? How is it a little bit more difficult? Well, for this one, we have it's not a fraction equals another fraction. So I need to combine these together first. Then I can do my butterfly thing. I should probably write down first, hey, I promise that I won't allow, let me scooch this over a little bit if I can. There we go. I promise I won't allow t to equal 0, right? Because if t equals 0, that would be a problem. And if t equal 2, that would be a problem. So t, you're not allowed to equal 0 or 2. Okay, so now at that point, I'm going to combine together this. So we have 5 over t plus 3 over 1. So I need a common denominator times t. So then this right-hand side of the equation is 5 plus 3t over t. And that equals t plus 7 over t minus 2. So it equals t plus 7 over t minus 2. At this point, I can do my butterfly, and now we're going to notice, oh gee, oh my goodness, this ends up being a quadratic. Oh, I'm not happy. So we get 5 plus 3t times t minus 2. 5 plus 3t times t minus 2, which is 5t, and then we're going to get negative 6t, so I'm going to get negative t. I'm going to get minus 10 at the end, and I'm going to get 3t squared. So I did that a little fast. You can use the box technique or whatever FOIL technique. So this turns out to simplify to or multiply out to 3t squared minus t minus 10. The reason I'm having to do that is because I now have one equation that has t, and it's a quadratic equation. So might as well, let's multiply everything out, combine like terms, and now we're solving a quadratic equation like we normally do. So this right-hand side of the equation is t times t plus 7. So t times t plus 7 is t squared plus 7t. Okay, so now it's quadratic. I'm going to get everything to the left side because I like my t squareds to be positive. I'm going to take away t squared from both sides and take away 7t's. So minus 7t's minus t squared. And let me move my graph a little bit here. Scooch on over. And so we get 2t squared minus 8t minus 10 equals 0. What I notice is all my coefficients are even, so I'm going to divide everything by 2, divided by 2, divided by 2, divided by 2, divided by 2. And when we do that, we'll get, I'm just cleaning this up a little bit since I'm running out of room. Good planning, Rich. Let me scooch this. Let me try it again. There we go. So then we get t squared minus, what was it? It was minus 4t minus 5 equals 0. This we can factor. T minus 5, t plus 1 equals 0. So t equals 5 is the solution. to this equation, and t equals -1 is also a solution. Are either of these on my list?